What is up, gang? Mr. B here, bringing another sweet, wicked, awesome math video. In this video, very similar to the last video that I just made, I'm going to take you through graphing and finding the inverse of a quadratic. If you need a little refresher on it, I would watch the last video first, because this one's going to be a little bit quicker pace, just because there's an extra step in it, so I got to kind of work a little bit quick. As always, like, share, subscribe, and here we go. Boom, into the screen. All right, guys, look, crazy Sunday of video making. But you know what? It's worth it because I love you guys, my students, and all my YouTube followers. Thank you guys so much for supporting me, cheering me on. You know, I've been on and off of this channel over the last few years, so I feel really dedicated to my job right now. I'm renewed. I'm just, things are going great. All right, so we have a quadratic in ax squared plus bx, so ax squared plus bx plus c form. Bad news. All right, we need vertex forms. You got two options: completing the square, don't want it. All right, I want to do it the easiest way. The easiest way is to use the axis of symmetry, which is my best friend. Okay, so first things first, get vertex form. All right, you need that vertex form. It's our best buddy. So if you hear some crazy racket going on, it's because I've got youngsters, guys. Yes, youngsters. All right, so I use this formula, x equals negative b over 2a, which gives us the x coordinate of the vertex, or the h value in transformational form, or it's the axis of symmetry. So I get negative b, which is negative 2, divided by 2 times negative 1 over 2. And if I do the math on this, it should give me 2. All right? You got 2 times negative a half is negative 1. Negative 2 divided by negative 1 is 2. To get the y coordinate of the vertex, I'm going to have to use my calculator probably. Maybe, I don't know, we'll see. Negative 1 over 2. I think I can do it mentally. 2 squared plus 2 times 2 plus 1. So 2 squared is 4 times negative 1/2 is negative 2 plus 4 is 2 plus 1 is 3. Look at that. How beautiful. With that piece of knowledge and the fact that our a value is negative 1 over 2 and that these are actually h and k, we can write our vertex form. Remember, vertex form is just transformational form of a quadratic. That's it, right? H just represents the shift left or right. K represents the shift up or down. And A represents, you know, the stretch. So we get y equals negative 1 over 2, x minus 2 squared plus 3. And there it is. That is our vertex form. Now, finding the actual, you know, inverse, what we have to do is switch the x and the y. So the next thing is find the inverse, and then switch x and y. You know, guys, I really have neat writing. It's just that this thing is so unforgiving. X equals negative 1 over 2, and y minus 2 squared plus 3. And I have a death grip on this thing. I don't know what it is, man, but when I grab it, it's just like, I don't even know. So then is we switch x and y and solve for y, okay? So that's what we're going to do first. So minus 3 from both sides, just like that. So it's x minus 3 equals negative 1 over 2, y minus 2 squared. We got to get rid of this 1/2, so we divide both sides by negative 1/2. Remember, dividing by a fraction is the same as multiplying by the reciprocal, so dividing by negative 1 over 2, same as timesing by negative 2. Great rule to remember. So I get negative 2, x minus 3. I don't want to see any fractions within fractions. That is a big no-no. And I should never use the word no-no again. The next step is we've got to get rid of that squared. We square root both sides. And remember, with each square root comes great responsibility of putting the plus or minus. So we have plus or minus square root negative 2 x minus 3 equals y minus 2. Now we need the y by itself. So we got to get rid of this guy. So plus 2, plus 2. Then we rewrite y equals 2 plus or minus square root negative 2 x minus 3. So what I want you guys to do now from this is we need to choose how we are going to restrict our domain of our original function. So normally that might be the very first step that I do, right? How we restrict our domain of y will affect everything else that we do now, okay? So I'm going to put that here as in the restricted domain of y. So what we want to do is we want to choose one side of parabola or the other. So we can restrict the left hand to, we can keep the left hand side or we can keep the right hand side. It's totally up to you. If you want to keep the left hand side, then you have to pick the minus in this, and it also means you're going to choose x is less than the x coordinate of the vertex. So the x coordinate of the vertex is our h value, which in this case is 2. If I want to keep the right-hand side of the parabola, remember, parabola just looks like this. So when I'm saying left-hand side and right-hand side, I'm literally meaning the left arm or the right arm. I keep the plus of the inverse, but I also choose x to be greater than or equal to 2. Totally up to you which one you do, unless there's some other restriction given at the beginning, which is possible. But for this one, there's not. All right, so we get to choose. So most people are going to choose the plus. I'm going to be the complicated one, and I'm going to choose the negative. All right? So that means our final answer for this is 2 minus square root negative 2 x minus 3. So I chose this, not that, undo, this as my restricted domain. X is less than 2. So that is for y. But what's important is that when you switch x and y from the y, or the original function, your domain of the original becomes the range of the inverse, because x and y switches, right? So our domain of the original means that our restricted value will be y is less than or equal to 2 for our actual inverse function. So now we're going to graph this quadratic using a mapping rule. So we'll take y is equal to x squared, and we got to remember our base table for a quadratic. Every base table for a quadratic starts off like this: negative 2, negative 1, 0, 1, 2. And then we're going to square all these, so 4, 1, 0, 1, 4. We're going to run it through our mapping rule. So remember, there's no b for quadratics, so it's just a. So it's x plus h, so x plus 2. So remember, that's x plus h. Then ay plus k. So your a is negative 1 over 2, y plus 3. So all these are just going to have 2 added to them, so it's going to be 0, 1, 2, 3, 4. And generally with these quadratics, the patterns work out very nicely. And then we're going to put the y values in here. So we get negative, or 4 times negative 1 over 2 is negative 2, so it's 1. And then 1 times negative 1 over 2 plus 3 is 2.5. 0 times 1/2 is 0, plus that's 3. And then we get some repetition, so it works backwards then, okay? Now the inverse, all we do for the inverse is switch the columns here. So negative 1 over 2, y plus 3, and then x plus 2. So this becomes 1, 0, 2.5, 1, 3, 2, 2.5, 3, and then 1 and 4. So now that we have that, we need to really think about how we're going to restrict the domain of that third, or not necessarily domain, but restrict that third table, which is the inverse. So let's go ahead and plot this quadratic first. It would be over here. So I get 0 and then 1. See if I can do this right. 0 and 1. So I'm plotting this middle table right now, which is just y, the vertex form. And then 1 and 2.5. And then 2 and 3, and 3 and 2.5, and then 4. Not over enough. So 0 and 1, 1, 2.5, 2 and 3, 3 and 2.5. There we go. And then 4 and 1, screeching baby in the background. I'm sure it's okay. You know, he's 1. He can fend for himself. Math videos are more important. I'm kidding. My wife's home. All right. So now this is our original y. The problem is it fails. This graph fails the HLT. So the horizontal line test determines if this thing is going to be a function or not. All right. So because I draw a horizontal line through this, boom, it touches 2 points. It means the inverse is not a function. So but I've already taken care of that, right? I've said that we're going to restrict the domain of y so that x must be less than or equal to 2. So less than or equal to 2, that's these values. That's the one we're keeping, and these are gone, right? Because those are greater than or equal to 2. So in terms of our transform function, these are the ones we're keeping. Because remember, if x is less than or equal to 2, then we want to keep the values of y are less than or equal to 2. These are the values for y are less than or equal to 2, but also they're the ones we transform, so we know we're going to keep the same points. And these are gone. So we can go ahead now and plot that little table with the top 3 points to get our inverse function. How can I do it? Here we go. So 1 and 0, there it is, right? And then 2.5 and 1 right here. And then 3 and 2. There it is. There's our y -1 such that it is a function and it passes the VLT. All right, so there's a lot going on with these questions, guys, and a lot of little things you need to remember. They come with practice. So my suggestion will be to you is, I've got 2 videos on this. This is one. What you could do is just do it over. Cover the thing up and do a question that you know how to do, that you know the answer, you just watched, and then go through it until you know the little things, the procedures, the things that you need to do. Then apply it to a different type of question. There's nothing wrong with doing questions over again because it really cements, that process. Like if you watch Steph Curry play basketball, he is the greatest three-point shooter in the history of the NBA. He practices his three-point shot every single day because he wants to keep knowing that exact same process. So even though he's the greatest, he still does the exact same thing, right? So even though you might know how to do this question, doing it over cements the process and makes you even better. And then he can apply that three-point shot in any point of the game, right? So it really makes a difference. All right, guys, I hope this video helps. This has been a marathon Sunday of math videos. Thank you guys for watching, and I will see you guys in class. Peace!
A lot of boring math.